Much, Richard, Leah, for joining us today. We'll hand over to you if that's okay.
Perfect. Cheers. Thank you very much. Hopefully it's obvious. I'm Leah. This is Richard. We run together. We are co-directors of Your Energy, Your Way. We've been up and trading for getting on for 8 years now. We install solar, all sorts of heat pumps, batteries, EV chargers, kind of the whole range of renewable technologies in people's homes. We have a mixture of just standalone projects where we'll just go in and do renewables. Then we get involved in quite a lot of renovations, refurbishments, extensions, new builds, that kind of thing. Just a side note, we are set up as a community interest company. So although we're a fully trading limited company, we are also very, very focused on getting more women into this sector. So we currently have 4 female apprentices that we're training up to be heating and plumbing engineers alongside our existing teams. So this is just what we'd like to talk through with you this afternoon. Little bit of just background about the kind of overall landscape when it comes to integrating renewables, moving towards that electrification of the home. Some ideas about how to prioritize, how to plan, what to do first. Lots of people come to us saying they don't kind of quite know where to start with all this stuff. How to plan it, and then a bit more kind of delving into the technical detail of a few different products, features, and how we go about choosing the right technology for people's homes. So I'm sure you'll all be aware of this big debate that has been raging for quite some time. Oh, I mean, you can't hear the dogs. There's some dogs in our reception. About whether to go with renewables first or fabric first. Obviously, that was a mantra for a long time. I would say there's been a decisive shift on that front in the last couple of years. Passive House Trust, as the kind of the statement says up at the beginning of the slide, and also the AECB, very much coming down on the side of actually heat pumps make an awful lot of sense to go in with first if you're really looking at reducing carbon. So this is an interesting little kind of fabric fifth suggestion from Nigel Banks, who works for Octopus Energy. So he's talking about air source heat pumps as soon as possible, then looking at smart controls, smart tariffs, how you use your electricity in the home, when you use electricity in the home, then looking at energy use and comfort. And that is when fabric kind of does start to come in. Then solar, and then a different kind of mantra to push back on the fabric first, fabric fifth. Obviously a little bit controversial, but an interesting way to approach things. Or there's a different kind of approach here from understandably the Solar Trade Association, as you might expect, suggests that maybe we should do solar first. So they've got a very useful categorization, I think, of different types of renewably empowered homes. So they start off with this notion of generation naught, a standard house with no renewables. And then first step, and often this is the journey that we find our customers go on. Although actually very often we find people get an EV first, and that sets them thinking about this. But then solar panels. It used to be we were always installing solar panels largely on their own and occasionally with a battery. Now, pretty much everyone who comes to us for solar now also comes to us for a battery as well. So that moves you into generation 2, which is really focused around the homeowner being able to maximize the amount of the solar power that they produce being used in their own home. So a battery for that purpose. And then many of our customers now are pretty much moving straight to generation 3, which is all about control and smart control, smart charging, smart use of electricity using cheap overnight tariffs in order to charge perhaps from the grid overnight, even on a day like today when your panels won't be producing an awful lot. So there's some really exciting things going on now in that space. We're come on to a little bit later, kind of the technology is sort of still getting there in terms of that whole home integration. But we really see a drastic lowering of customers' bills and their CO2 impact when they bring all this together in terms of charging from the roof, charging from cheap electricity, having a large amount of battery storage. And then the solar trade guys have a concept of generation 4, which is where we find most of our customers land up, which is also getting a heat pump. And then being fully electrified and able to work smartly between all those devices. And at any point along this roadmap, they might also choose to upgrade the fabric. So hopefully you can see something there about how this can reduce CO2 emissions, and just an idea about these are the different kinds of things that we're talking about when we talk about integrated renewables.
Just
So, on that, Leah, then how do you lead that conversation with your clients? I mean, it's quite interesting. I haven't seen this solar first chart before. Obviously, there's a lot of noise around. Well, I don't suppose it's just what you're exposed to, but there was a lot of noise around fabric fifth and heat pumps, etc. I quite like the idea of the generation 3. Is that so those guys, are they new build? Are they people that are just looking at completing overhaul renovation of their existing property, or is it a combination of both that are coming to you?
We're seeing more of the new build kind of going straight to the whole hog, really. So when you're talking about generation 3, it's often existing houses. And we find there's a lot more confidence out there in the market about solar PV just as a technology in general than there is about heat pumps. So often we take our customers on a journey starting with installing solar panels and a battery, and then that opens the door to then begin to talk about a heat pump. So yeah, it's a more straightforward install. It's less intrusive in the home, and it does also, and we're going to come on to that in a sec. It is the thing that probably cuts your bills more than if you were to go straight into installing a heat pump.
Yeah, and as Leah says, it's often a journey. So the quickest way for somebody to decarbonize and save money is to do everything at once, because there are economies of scale of having people on site doing all the work, and actually lots of the technology is works together very nicely. So you're using a heat pump to heat your home that uses electricity. Where if you can power the heat pump through solar, or more likely in the winter through a battery charged at an off-peak rate, then that makes the whole thing work together much more nicely. So they work together as a good package, but obviously there's a significant capital investment to be made in doing it all in one hit. And I just quickly want to pick up on something that Leah said about electric vehicles, because often this is the way that people get into the technology.
Yeah.
They start off with an electric vehicle and they think, okay, well, this is great, but it costs me quite a lot to charge it. And then they move on to an energy tariff, which enables them to charge it at an off-peak rate, which is very cost effective. And then they start to think, well, why can't I power my entire house at an off-peak rate? And then they maybe think about solar and a battery, and they put those in. And then they think, wow, in the summer, I'm producing so much energy. What should I do with it? Oh, I could use a heat pump and I could power a heat pump. So that's a very rudimentary journey, and it's often more nuanced than that in reality, but actually that's the kind of simple journey that often a stakeholder or a homeowner or a business owner will think about.
Cool. Can I just check, guys? Can everyone see the presentation on the screen? I've just had a message saying that they can't see it. So if people could just put in the chat that they can, and that'd be great, just so I know. Yeah, that's fine. Okay, that's cool. Thank you very much. Cheers, guys. Just had one message, and that's good. Cool. Lots of yeses. There's another question. Well, there's a couple of questions that's come in, Rich. I'll try and manage it so I know that we can get through the presentation. But let me just
It's
address.
fine. We haven't got hundreds of slides, so
No,
yeah,
that's fine. Cool. 2 secs. Now I can just. Rob's just asked about peak shaving and the definite, and what do you mean by that? And he's presumably not extreme hair loss, unlike me.
Yeah, so there's a couple of things really. And we'll talk about this a little bit as we go through the slide deck, but certainly touch on it now. So when we talk about time of use energy tariffs, they often have a peak rate, and generally speaking, in the UK, the peak rate for energy in terms of cost and carbon is between about 4 p.m. and 7 p.m. So there are two things that you can do here. If you install the right technology, it enables you to avoid that period, which means that you can avoid the high cost of that period if you're on a time of use tariff, or even if you're not, you can avoid the high carbon, which is associated with 4 p.m. until 7 p.m., which is pretty much universally when the grid is at its most carbon intense. And the other thing is that you might find that your home has such a significant energy load. Perhaps you've got lots of technologies going on that battery technology can supplement that energy load. So you might find that you're drawing a particular amount of energy at a particular time. Well, with the right technology, you can install the right technology to enable you to reduce the amount that you need to take from the grid at that time.
Cool, thank you.
Yeah, so I was
proceed.
going to say, you'll have seen things from electricity suppliers, perhaps personally at home, demand side response, DSR events. So if you're an Octopus customer, for example, you can sign up to be notified if there's one of these particular pinch points, and then they in quite a small way, I think I earned 65 pence last time I did this, they incentivize you to downscale your electrical use during that kind of a particular hour or something. So that's just the beginnings really of the grid starting to try and drive consumer behavior through incentives, but we'll only see that kind of stuff increase in terms of the way tariffs are structured going forwards.
Yeah, absolutely. I think last year they started running these. When I say last year, I'm actually talking about pre-Christmas 24. So would have been November 23. The grid started running these demand side response DSR events. And at the time, it wasn't unusual for our customers to be essentially covering their entire electricity bill in one hour or 1.5 hour DSR event, because the incentives for reducing or exporting energy at that point were so significant. This year they've cut back on it quite significantly, but I think what it shows is that they are gauging what the right price point is to get people to interact with these DSR events. I think probably the first time round they over incentivized, and this time around possibly they haven't incentivized enough. So I think we'll see that shifting and changing, and having the right tech can mean that you can take advantage.
Cool.
Perfect. So I think these slides kind of trying to give some ideas about how to approach these installations, these pieces of work. So we very much start with customers about what is it that you are trying to achieve. And obviously people come to us for solar panels or heat pumps, or they're doing a renovation, whatever. They've all got very different motivations. So is it about bill reduction? If it's about bill reduction, the first place to start is solar. It's the quickest way to actually see a good saving. If you haven't got a battery, you can save 30% of your electricity bill. If you have got a battery, even without doing time of use tariffs and charging off peak, you can save around 50 to 70% of your electricity bill, obviously depending on the size of the battery. Also, we are finding increasingly, if people are upgrading or renovating, people are incredibly reticent to put in new gas boilers. They're kind of, I'm upgrading my home, I'm making it hopefully more saleable, more attractive. I really don't want to stick with a fossil fuel technology. They can see that the direction of shift is towards heat pumps. And obviously, when you're doing a load of work anyway, it's a great time to put in a heat pump. If you're trying to get the quickest CO2 reduction, you'd actually go in a different direction. So solar for bills, heat pump every time for CO2 reduction. And then also, obviously, as a lot of architects on the call, future home standard, we're really hoping that comes in soon. I'm not sure whether you might not be, but from our perspective, that's going to mean a real sea change in terms of new builds, and how difficult it will become to put a gas boiler into a new build. So obviously that's going to drive a whole host of behaviours, although it still hasn't fully landed as to what that's going to look like. On
that, if people are designing to REBA 2030, then we're assuming that future home standard is going to be similar to REBA 2030. So, we start being aware of what's involved now, then you're only future-proofing your business, that your practice and your clients who end up with a home that's going to be, like you say, future-proof.
Yeah, exactly. And then I think sometimes a forgotten story about heat pumps. We're seeing more and more people out there in the country at large use their heating less and less in order to save money. So people kind of just running their gas boiler for a couple of hours in the morning or a couple of hours in the evening, working from home, really chilly. Heat pumps, you can, even without kind of having a battery or having solar, you can keep your house constantly warm for about the same price as running your gas boiler for short bursts in the day. So it is a more, I have a heat pump at home, I have done for 5 or 6 years. It is a more comfortable way to heat your home because you just keep it ticking along rather than kind of suddenly a big burst of heat that's then gone and you feel cold and then kind of comes back. And so it is a part of the comfort piece, particularly if you're also doing insulation at the same time, because obviously, as we know, that increases comfort too. And then, yeah, going back to this peak shaving kind of idea, this just a little graph at the bottom here to show at the moment we as Richard said, have an issue that when electricity is in high demand, we tend to rely on more on gas-powered generation and more on even standby diesel generators that there's a fleet of out on the grid, which obviously are really poor in terms of CO2 impact. And we have some pumped storage, some hydro pump storage, particularly there's a big plant in North Wales that you can go and visit, Electric Mountain it's called. So that's kind of our current, the graph on the left is the current pump storage that we have available. So this is just a little slide to say if we just had 4.4 million generation 3 homes that had a 10 kilowatt hour battery, we could do over and above what we've already got in terms of pump storage. So that whole just not having to build extra power stations in order to deal with pinch points, but being able to have responsive kind of coordination from millions of homeowners that can balance the grid and bring down that those pinch points.
Yeah, and I just say back on the comfort point that Leah was making, I like to describe the heat pump more as a slow cooker, whereas people might be using a gas boiler as a frying pan. So you just got that low, even temperature, which makes it more comfortable for inhabitants.
Just whilst you're talking on this slide, Rob's asked a question about the national power grid, and he's asking, is it true that they run an auction every 30 minutes for energy providers to offer their lowest price, with that price then being set for the half hour of supply? This would further incentivize the use of batteries to charge when prices are low if you are using the grid to top up.
Yep, that is correct. There's a tariff that you can use which actually uses that information. So Octopus Energy have a tariff called Agile for incoming and outgoing. So when I say incoming, I'm talking about incoming power, so the power that you use, and outgoing, I'm talking about the power you're able to export. So they have an algorithm which then looks at the wholesale price of energy in 30-minute windows, and that algorithm then sets a price for the customer. So that information gets released 24 hours in advance. And with the right technology, you can utilize agile incoming and outgoing prices to buy and sell energy. It's a little bit of it's not a lottery. A lottery is not how I would describe it. But when it's good, it's really good. And when it's bad, it's really bad. So there was a period of time a few years ago where the wind was blowing. There was a lot of energy being generated overnight on a very consistent basis, and people were being paid to charge their electric vehicle. I say people, I was one of those people when I was utilizing that tariff. But not long after that, the rates went to the other side of the coin, if you like, and I was thinking, I can't charge my car; it's going to cost me too much money. So you have to kind of be prepared to ride out the good and the bad, and most people don't want to do that. Where we tend to see people doing that is where they perhaps they're living on their own, or they're just a couple and they've got plenty of energy and they don't actually use very much, and so they can export and get the benefit there. Where people are perhaps busy people, their families, they need to charge their car so they can get to work the next day. They don't want to be worrying about when to do that. But there's technology out there and people can install. We can install it too, which enables you to take advantage of the highs and the lows of the 30-minute pricing.
I think what we've seen is it's altered the kind of installations that we do. So previously, where we might have seen a couple in a large house, just the two of them, we might have advised them to go relatively small on the battery and the PV array, because they were just not going to use that kind of amount of power. Whereas now, if they're interested in this kind of approach, we're much more saying, you can benefit from excess energy that you're generating.
Cool, thank you.
So I think this one's over to you.
Yeah, it can be over to me. Yeah. So in terms of planning, what you want to do, we've had the discussion around whether what I term as quite a simple exercise of, do you want to save money or do you want to save carbon? If you want to save carbon, you go heat pump first. If you want to save money, probably go solar PV and battery first. And the reason why I say solar PV and battery speaks very much to the first item on this slide, which is the battery and inverter. So your choice here is quite important because it's what enables you to take advantage of some of the things that we've been talking about in prior slides, such as this dynamic 30-minute pricing, but also the amount of energy that your home actually needs. Do you want your system to be able to power your heat pump or your electric shower? Or I'm sure this won't be strange to some of you, but we do have customers who have got saunas, jacuzzis, swimming pools, and they want it all powered and working by their renewable system, which is obviously a very different situation to perhaps a couple of people who are retired living on their own and want to make use of what we call energy arbitrage. So powering their system when it's very cheap and then exporting the energy when it's much more costly in order to maximize their return on investment. So that battery inverter piece is really important. What are you looking to power? Do you have particular needs? So do you have unreliable power in your local area, for example? Do you think you might get power cuts, or do you have things which a power cut would impact quite significantly? Funny example, but somebody might have a pond pump and they've got some really expensive koi in the pond and they want to be able to keep that running. So is whole home backup an answer for them? And that will dictate which type of battery inverter technology that they choose. Then, and this is really important because people often don't think about this, but do they want a level of control which is very specific, or do they want to set it and forget it? And that's really key because there are a couple of pieces of technology out there that we use where you put in your tariff information, it makes all the decisions for you, and it does everything for you. You don't have to think about it. You can just look at it in future and decide or see how successful it's been. Or are you somebody who likes to really tweak things and get into the weeds? And then we might suggest a different piece of technology where you can utilize your own skills, maybe it's the programming skills, using something like Home Assistant in order to be able to govern exactly what happens when, particularly if you've got a home which is perhaps fully automated. On the solar side, it's not really about the technology, it's more about the aesthetics. So if you're doing a redevelopment, are you going to want the panels inset into the roof because people often think that looks a lot more aesthetically pleasing? Do you want to have panels which look all black? All black tends to, given the nature of the color, blend into the background a bit more. And some people are very particular around how things look, others less so. Perhaps if you're having it at the front of the home where it's visible to all your neighbors, you're more concerned with that. Maybe not so much at the back. Have you got much shading now or in the future? Because then that might dictate the technology that's suggested in terms of the panels and the inverter actually technology that we use. And a little bit back to what Leah was saying before, are you looking to maximize or are you looking to satisfy? And what we would tend to say, as you might cynically think, we would say maximize. But the reason we say that is through our own personal experience. Myself as a consumer, before I got into this industry, I was told that I needed a certain amount, and knowing what I know now, I always wish I'd got more and maximized as much as I could. But also because very practically speaking, you've got a set of costs which are associated with an installation, scaffolding, man time, notifications, sign-offs, etc. And that all takes time and money. And so why not maximize? Because you don't, this is not something you really particularly want to revisit, particularly in terms of solar panels going forward. On the heat pump side, it's really about monitoring and control with a particular focus on control. So a little bit like the PV and the battery and inverter, how much control do you want versus setting it and forgetting it? The aesthetics are also important. Some of the newer heat pumps look quite pleasing, kind of a grey appearance in terms of how would you describe the color of some of those units? Like grayscale, kind of
Well, the
slate
old ones.
almost.
Oh,
No,
so like
yeah,
black.
yeah,
Yeah,
like
slate black.
black or slate look, which actually looks quite aesthetically pleasing, versus some of the older ones, which tend to be much more like an air conditioning unit, so kind of white with a big fan in the front, which perhaps looks less aesthetically pleasing. And then it's about choosing the right installer. Do they have the experience of getting it to work a very efficient way rather than just putting it in and turning the temperature up? And finally, a point on supply chain and country of origin, which is becoming more and more of an issue. So, are you particularly concerned about where the unit's manufactured or where the supply chain picks up the resources? So, we're seeing more customers who would prefer not to have any implicated slave labor in the solar PV modules, which is often an issue with production and raw materials from China, or perhaps you have a particular distaste for somebody who works for a particular company, perhaps their CEO, and you decide you don't want to utilize their
You're
equipment.
mentioning no names.
I'm mentioning no names, or equally country of origin. There's obviously a lot of politics going around as there always is, and that might influence your choice in terms of supply chain ethics and country of origin.
So who has, I don't have any storage. I mean, apart from, um, I mean, what's the most popular battery storage supplier out there? Is it Tesla or is that the one that
Probably,
people go
yeah,
to?
probably, yeah, probably is Tesla. Tesla have what I would say is, from many circumstances, one of the best products on the market. And probably what we've seen, without wanting to get too political, is somebody who people have thought was a little bit of a sustainability hero turn into somebody who's much people have much less appetite for. Not always. I went to see a customer before Christmas who was determined that they wouldn't have anything Chinese because that wasn't ethical, but was happy with Tesla. And I saw a customer the next day who thought Tesla wasn't ethical, and were quite happy to look at Chinese. So the point, I guess, is that ethics aren't necessarily black and white. It's kind of
No.
people accept. People are typically more accepting of solar panels because there's not a lot of technology in them, regardless of where they come from, but perhaps less accepting of a piece of technology which is manufactured in China, which has electronics in it, such as a battery and inverter. They may be a little bit concerned by some of the press which has come out over the years around this level of state control. So it's a really complicated picture for us to deal with, and which is often unique to a particular customer or architect or business.
Yeah, I mean, and actually, just picking up on that, the couple of people have sort of brought up the notion of embodied carbon and sort of how that's prevalent within the panels themselves. And Iona mentioned, so I'm just trying to find Iona's point. Um, how sustainable current are the storage batteries themselves in terms of their production versus lifetime. So, there is this payoff as well from an operational side,
Yeah.
ethics and the embodied carbon of doing such a
Yeah. So I'll just pick up on a couple of those points. So embodied carbon is really difficult. There's lots of different ways of calculating it. I guess if somebody's very, very focused on embodied carbon, they'd probably end up doing nothing because that's the best way to save carbon is just to use what's already out there and not do anything. It's a really difficult one. On solar PV modules and embodied carbon, typically they have a warranty of 25 to 30 years. And even after that point, we'd expect them to continue operating. So they have quite a level of longevity, which should pay back the embodied carbon. On the batteries, particularly on the usability, a couple of points there. So most batteries have a 10-year warranty, Sometimes it's a little bit more, sometimes a little bit less. It's usually a 10-year warranty with a minimum of 70 or 80% usable capacity of the battery after 10 years, which means that you get to year 9.5. And if you've dropped below that usable capacity, so let's say you had a 10 kilowatt battery, you dropped less than 7.5 usable kilowatt hours of capacity, then it would be due for a warranty replacement. That's not to say that at the end of 10 years you need to replace your battery. We would fully expect the battery to continue operating, but equally, your warranty's out at that point. So if you got unlucky and you had a fault, you wouldn't be covered. What we've seen, there was a battery manufacturer, I won't name them, but I signed up to a scheme with them a few years ago. And what they were looking to do was reuse second life electric vehicle batteries and then put them into home storage. They actually pulled the pilot because there weren't enough second life EV batteries to put into home storage because they just didn't fail. And if they failed, then they would be repaired relatively easily. So I think longevity of batteries, particularly as we see the evolution and maturity of the technology over the last 5 years, I'm not overly concerned about longevity of batteries as it relates to usable capacity, but you could always get unlucky. Everything's got a warranty. Once the warranty's gone, if you get unlucky, that's kind of life, isn't it? But I don't feel overly concerned about that. And on the batteries in relation to embodied carbon, I think the thing that often gets forgotten is when energy is cheap, it's almost university when it's at its least carbon intense. So the lowest carbon footprint related to energy when it's cheap. So if you can utilize your home battery to use energy when it's cheap and therefore low carbon, you are really minimizing your carbon cost over the long term.
Yeah, I think batteries is a really tricky one to work out when it pays back its embodied carbon because it's so much whole system. So you on your own with one individual battery, you can't do a calculation of when that one battery is going to pay back its embodied carbon because the impact of your battery is only significant once thousands of people have batteries and we start doing things like building less power plants, which obviously has a massive carbon saving. So it's a very, very difficult calculation to do. I would say on the heat pumps and solar panels, they are paying back their embodied carbon in less than 5 years. With solar panels, it's a year. So yeah, that's obviously much more calculable and much very swift.
Cool. I know this is I'm right in thinking this is your last slide. We've got a bunch of questions, so I'll let you finish up here, and then we can address some of the questions that are coming.
Yeah, sure. So a complicated slide, but I guess the simple message is that where we are moving from is kind of the top left of this grid. So it started off with having solar PV. How can you use your excess solar PV? And we're at a point now where pretty much every battery on the market enables you to use any excess solar PV. So you can do what's called maximize self-consumption. So that's maximizing the amount of energy that you've produced that you consume yourself. And the follow-on to that was to put that excess energy into a car battery and then maybe into a heat pump or into an immersion heater. Where we have moved to now is utilizing these complex TOU, so time of use tariffs, which, as we said a couple of slides back, typically people, their first experience of a time of use tariff is when they move to an electric vehicle and then move to a time of use energy tariff to charge their EV. And it's utilizing the technology to enable you to make the best use of your time of use tariff, which will save you money, but also save carbon. So that's a home battery, someone like Tesla with their Powerwall or SIG Energy, Enphase Give Energy. There are others that you can utilize, some via a third-party app, such as Home Assistant, which enable you to make use of complex time of use tariffs with your home battery so that you can be mostly, if not all, off-peak with your energy usage. You can also use EV charge points, or EVSE, which stands for Electric Vehicle Supply Equipment, to charge a car battery. So My Energy Zappi, the Ohm Pro, Hypervolt, there are others which enable you to tap into some simple and more complex time of use energy tariffs to charge your EV. And again, with the right controls on your heat pump, which comes back to selecting the right installer and selecting the right heat pump, you can have your heat pump run to take advantage of a time of use tariff as well. And probably the last two columns, immersion and smart sockets on the right-hand side of the presentation. Less relevant now. They used to be really relevant, but they're less relevant now. And the reason they're less relevant now, but not necessarily going forward, is all about energy prices. So right now, with time of use energy tariffs and with the way that the energy market has gone, it actually makes more sense to export your excess solar and utilize those time of use energy tariffs rather than use excess solar to heat your hot water, for example, or run a smart socket. That's just the nature of energy prices right now. And I would say probably for the last 2 years or so, but it could change going forward. So in the green, you've got what's important now. Then one day we'll have V2H or V2X. So V2X stands for vehicle to home, grid, or load. There have been some trials on vehicle to home. There have been some trials on vehicle to grid, sorry, but not much in the way of vehicle to home. Hasn't been hugely successful. I would say that we have probably removed more vehicle to grid charge points than installed. But I do think it's a really key opportunity for the future in terms of how we decarbonize. If you think an electric vehicle battery, if you're not aware, it's probably got a 50, 60, 70, maybe even 100 kilowatt hour battery in it, whereas a normal home battery might be 10 or 15 kilowatt hours. So hugely more capacity in your electric vehicle than you've got in your home battery. So being able to combine your home battery to partly or wholly power your home will significantly help decarbonize the grid and reduce your costs. Right now, we can install a vehicle to home EV charge point. It's officially only compatible with 1 or 2 cars, and the cost is quite significant. But maybe in a year's time, it'll be different. However, I have been saying maybe in a year's time, it will be different for probably 3 years. So it's coming.
We do have one customer who his roof is just totally unsuitable for solar. They went with a heat pump, and they have an older Leaf, so it's got a 30 kilowatt hour battery, and they do charge that battery up cheaply overnight and then use it to kind of run their heat pump for a good portion of the day. So it does work, but it is still very limited.
Yeah, and Rob Llewellyn, he was on many months ago. He was talking about vehicle to grid and how he uses. I think he has a Leaf as well that he uses that for.
Yeah, so I think it's definitely part of the future. There are some challenges which I won't go into the detail of, but essentially part of the challenge is 2 different standards of power. One is called CHAdeMO, which is old, and most new cars do not have that. They tend to be Japanese, but it has two-way power written into the way that the technology works. And we've moved on to a new rapid standard in the UK and Europe, which is called CCS2, and that does not have an agreed standard for two-way power. So that's part of the complication, and that's been the case for a long time. The other thing is that we've got lots of different technology on this slide. There's not really one manufacturer who does it all. Probably the closest is Give Energy, maybe SolarEdge or Sig Energy, but they're not necessarily the best technology. And then we've got something totally different on the heat pumps, which tends to be homely smart thermostat and controls. So we don't really have one app to manage it all and run it all, which is where we see some people kind of tinkering and using Home Assistant to try and control it all. But it's another level of detail, which I would say 99% of customers have no interest in.
I understand that. Thank you for that. I'll just work through some of the questions then, guys. Anna's asked, is there any sense having battery storage and a heat pump? For example, in London townhouses often have space for only 2 or 3 solar panels.
Yeah, that's a really good combination. So on a day like today, which isn't quite as freezing cold as it has been, your heat pump could well be running on an average sort of size house using perhaps a kilowatt an hour. So if you've got a nice decent 13.5 kilowatt hour battery, then you're running your heat pump for good half the day off that overnight cheap electricity. So yeah, that's a really nice combination if you want to go that way, even without solar panels, as long as you can get yourself a cheap overnight electricity tariff.
Yeah, so just on that, I would say that the combination of solar panels and battery work really well together, because it's not what I would term a one-trick pony. Batteries work really well when you've got a time of use energy tariff, which enables you to have an off-peak period. and their payback is largely related to the difference between your peak and off-peak periods. If the difference starts to shrink, then the payback on batteries starts to reduce. Solar panels work really great when the sun's shining, but when the sun's not shining, you've got no energy that you can save. So combining the two together works really well, but there are always going to be some circumstances where you just can't fit enough solar panels, or putting, two in place is not going to be worth the cost of the scaffold or something of that nature. So where you've got an environment where you've got time use energy tariff and you could take advantage of that, it absolutely makes sense. Now, dependent on your energy supplier, most energy suppliers all energy suppliers at least have the original Economy 7 tariff, where you've got a day rate and a night rate. And at the minimum, you could have a battery which is charging on that night rate on Economy 7 to get your return and make things run more cost effectively and with a lower carbon cost. And in the best case, you have an electricity supplier which has got perhaps a heat pump tariff, which gives you a couple of different windows of off-peak energy when you need it most, and you can charge your battery and run the heat pump at that time as well. So yeah, absolutely makes sense.
Cool. And what's your experience with solar tiles? Are they becoming more prevalent? Did you recommend down to that level, or do you just recommend solar and it was more traditional panels? How do you address the new tech coming in?
Yeah, we have done some installs with solar tiles or solar slates even. Unfortunately, their output is still really low compared with standard panels.
Yeah.
In the area that we work in, southeast of England, lots of very congested roofs. So, everyone's got a Velux and three dormers in their roof. And the issue with solar tiles is it tends to be that you can't cut them. So very often the amount of the overall roof that you can actually use the solar tiles over can be much reduced, because anyway, you've got a hip or a valley or
Right,
whatever.
right.
You've got to keep away from those spots. So they are definitely an option. I am also just slightly wary of the amount of cabling that they require. Because somehow you've got to get the power back from, often they're in a bank of like kind of three, but then each three will have a couple of cables, and it's doable. It has to be in some areas where there's conservation areas, but we would much rather do an inbuilt panel that looks like a Velux than go with tiles or slates if we can.
Cool.
Yeah, I agree with that. You need to have a really specific reason for using them. So you're in a conservation area or a listed building or something where it has to look like slate. Otherwise, not generally cost effective.
Okay, thank you. Lindsay's asked, what are your views on phase change water heaters?
Definitely a very good idea if you're limited for space. So I should have said with the heat pump, you do have to have some sort of hot water storage. And so that means typically a hot water cylinder, which would have gone in an airing cupboard. Often airing cupboards are being turned into extra cupboard space. So yeah, we do install some of the SunAmp phase change heat batteries. They work really nicely. They are more expensive than just putting in a hot water cylinder, and because effectively they come into the property filled, they are incredibly heavy. So if you are thinking of installing them, you really do need to think about how you're actually going to get one into the building, and how you're going to make sure that the floor is sufficiently strong enough to hold the weight. I mean, in that sense, it's the same as a cylinder, but it is just getting it in heavy.
Cool. Piers has asked if there's a general rule of thumb for how much solar PV for a new build 4 or 5 bed house. What sort of
Much as you can fit. As much as you can fit. I mean, if it's 4 or 5 bedroom house, then you'll be using lots of energy. If you're using a heat pump, even more so. So yeah, absolutely max it out to the benefit of the homeowner and to the aesthetics of the building. Take that into consideration too. But yeah, absolutely max it out.
We come to a lot of new builds where, for I'm sure sensible reasons, very few panels have been put on, and customers are asking us to put on extra, and it's just awkward and messy, hard to match up. So do it while you can.
Yeah, absolutely. It's not unusual for me to go and see a new build property with a homeowner who says, I've got 3 panels, can we have more? And it's 3 panels in the slap bang right in the middle of an enormous roof. And it's just so frustrating because, for them, it's been a box ticking exercise for the home builder, for the house builder, and a bit of missed opportunity with additional expense involved in putting it right.
Yeah. Um, Annabelle is asking about, she's read about hybrid heat pumps coming under the bus grant, but she can't see confirmation of this. It's not 100% clear how a hybrid system works. Have you any experience with them?
Yeah, so I am not currently sure when it's going to come under the bus grant, but MCS, so Microgeneration Certification Scheme, who kind of govern our installs, are now allowing hybrid heat pumps. So I'm assuming it's just a matter of time before the bus kind of lines up with that. You can set them up in a few different ways, either to maximize minimize cost, I guess. So the controls will move between the heat pump and the gas boiler depending on which is the cheapest to run at a given time, or you can set them up with a set, it's called a bivalent point. So maybe you can't put big enough radiators in the house. People want those lovely cast iron ones which look beautiful and give out no heat. So you might say, well, if it gets below 4 degrees, then we're going to switch over from the heat pump. Sorry, 4 degrees outside. We're going to switch over from the heat pump to the gas boiler because the radiators aren't sufficient enough to be able to get that much heat out into the house. So there's a couple of ways you can do it. The other way you can do it is to take away that need that I mentioned before for a hot water cylinder. So you could keep a gas boiler constantly doing the hot water, which can be useful if the customer just cannot find a space for a tank or a sun amp.
She's also asked if you have you ever installed air-to-air heat pumps and where you might benefit from doing so.
Yeah, so we do air to air or air conditioning as it's kind of also known. It works. You've got to have some other way to heat your hot water because you're not going to get hot water heated through an air to air system. If it's a new build where customers are kind of going to be happy with having air blown at them rather than more traditional radiators, it's much cheaper to install than putting a wet system all around the house. Or it can also be an extra top up if the customer wants to sort of have underfloor heating downstairs. Maybe they'll go with air to air upstairs because that gives them a little bit of cooling as well as heating. It will be interesting to see how the whole hybrid piece develops within the regulations, BUS and MCS, as to whether going forward we'd be able to get the grant for a system maybe where you had a wet system downstairs and air to air upstairs. Still not clear.
Just picking up on the point about previous point, Richard, where you talk about have a lovely large roof and someone's designed it so there's 3 solar panels smack bang in the middle. What's your biggest frustration? And when it comes to working with architects, how how prevalent is renewables and positioning of solar panels in mind when it comes to designing roof shapes, etc.? Are there any common frustrations you have there? Any wish lists that you would like people to be mindful of?
Yeah, our experience is that the roof looks fantastic, but it's not very good for renewables. It's generally our experience. Um, and typically, what will happen is a homeowner will be interested in renewables and say, "These are the plans that I've got. Where can I fit panels?" And it's a perfect roof if you're looking at it from the north, but that's the worst place to put panels because that's where they're going to get the least sun. So, yeah, I think the earlier you can think as an architect, you can think with your client about how important the renewable aspect is going to be to them, the better, because then you can start working with somebody to factor in how things are going to be fitted and integrated into the home. I think that's going to be really important. What we often see is quite complicated roofs or south-facing roofs with lots of small dormers, too small to put a solar panel on or a couple of solar panels on, for example, which then really restricts what you can do from a solar perspective. But also then you have to think about where you're going to put the plant room. You've got a lot of technology going into the plant room or utility space, whatever you want to call it. So if you're having a heat pump, you've got bits of equipment in there. You've got to get your cabling down from the solar panels into that area. Where's the consumer unit going to be? So the practicality of where the plant room is going to be, I think, is another aspect which is worth
You
considering.
mentioned location of batteries.
Yeah, location of battery, that's a good one. Our preferred location for batteries is outside. So can you find a space to put it outside, just outside the plant room would be perfect. inside is not the preference unless it's a really big home with a very dedicated plant room. Sometimes we see homes where the plant room is essentially at the back of the garage. That's fine. We can put the equipment there. But the batteries are quite big, so it's not unusual for a battery to be maybe over a meter in height, perhaps 3/4 of a meter wide, and maybe project from a wall 20 centimeters, something like that. So you're talking about the size of perhaps a small bookcase, something like that, and it's worth thinking about that.
Cool. Okay, doke. Just got a couple more questions. Ian's talking about installing solar panels in the back garden when there's a problem with an existing roof. I mean, how prevalent is that? Well, obviously it depends on the size of the garden, the position, etc., etc.
Yeah. So you can do a ground mount. In some ways it's easier, but you do have to have the land to be able to utilize that. So, and we have to think about cabling as well. How are we getting the cabling from wherever the system's going to be installed back to the plant room?
Mhm.
And anything more than I think it's 4 panels needs planning permission.
I was going to ask is what sort of planning is required for?
There's a meter squared, that you have to ask if it's over. I think it works out about 4 panels. You can't go more than that without getting planning permission.
Okay, doke. Picking up on the different shapes of roofs, etc. Kevin's asked, are there any PV panel systems available that give flexibility to be shaped or cut to respond to those hip roofs that you're talking about?
Not really.
There is one company called GB Sol who do like bespoke made to measure solar panels, but they're the only people I'm aware of. Yeah, and frustratingly for us, actually, they have got larger over the last couple of years as well. A standard panel used to be about 1.68 meters long, and they've now gone to nearer 1.71, 1.7.
Yeah.
72. So quite often customers will come to us and say, oh, I've found these 500-watt panels. Why are you only speccing 370, 380-watt panels for my roof, or 400-watt panels for my roof? It's because the 500-watt ones are enormous and intended for solar parks in fields.
Right.
And actually, even having gone from that 1.68 to 1.72 has caused us problems in the part of the country that we live in, because we just have so many complex roofs to deal with. So yeah, it's a bit frustrating.
Actually, that is a good point. So the other thing to consider if you're planning as an architect, if you're designing a roof, you can't utilize the full roof space for a solar PV panel. You have to have a clearance around it. So what maybe you think might fit doesn't necessarily when you take the clearances into account. So just worth bearing that in mind too.
And also in-roof panels have plenty of flashings around the outside, so you've got to allow room for them, and then for the tiling or slating that goes onto the flashing to then make to the edge of the roof.
Yeah.
Okay, just on solar panels, John's asked if there's a typical lifespan before they need to be replaced.
They just keep going. I mean, most have a 25 or 30-year warranty. At the end of that warranty period, we wouldn't expect to need to replace it. It's very unlucky if you get a panel which breaks, and often it would break through physical damage rather than through any deterioration of the actual components themselves. So that is we never get asked to replace panels.
Interesting. I thought that okay. I didn't realize they were so long lasting. That's cool.
Yeah.
Before I just get on to Nicola's question, I'll probably end with Nicola's question. Bart's asking if you have any experience of retrofitting air-to-air heat pumps in houses that have ducted systems already in place.
Yeah, so you're talking about a hot air blown system,
Yeah,
right?
you're talking about homes with hot air gas heating, yeah.
Yeah. So unfortunately, those systems are designed to work with a really high temperature. So heat pumps typically are running at low temperatures. And so marrying a heat pump directly into an air blown system is really difficult. We are aware of, is it they're called Johnson?
Starley Johnson,
Johnson.
I think it is. Yeah.
So yeah, one company that make a lot of these systems that keep promising us that they're about to bring out a high temperature heat pump that will work with their system, but it's yet to appear.
Yeah, work with low temperature.
Sorry, yeah, sorry,
yeah. Because at the moment you could run it with a high temp heat pump, but then you've got really high running costs.
Yes, sorry, so they're bringing out a system hopefully, but currently, you really need to kind of redo the heating system for the house. So that's either putting in new ducted, and maybe you can utilize some of the existing ducts, but they tend to be low rather than high. So normally, if you're going to put in a ducted system, everything's running at ceiling level. Most of these systems run at low level. So yeah, it's a really difficult one, and you often end up just taking it out and starting again.
Lastly, Nicola's just made the point that she's having, or they've had issues with planning around heat pumps in her area of Oxford City Council due to the noise from the units. I mean, that's well, people talk about the noise, but I thought now they're just getting quieter and quieter. And I've seen Graham Hendra post videos where he stood in front of his unit and he was like pretending that you can't even hear it. You can't even hear the unit. So obviously, if that's the issue, Nicola, then it's unfortunate. I'm not sure whether you've had any experience with that, guys, with that issue, guys.
So planning is in flux right now. Just before Christmas, the government made an announcement that the planning standard is going to change. Obviously, they make a lovely announcement, and then it takes some while for it to actually be implemented. So there is a noise calculation that as installers we have to do to work out what the noise of the heat pump would be at the nearest livable room window. So that's a lounge or a bedroom essentially. So the planning standard will change, and if you just search it up on Department of Local Government, there's a news announcement about what will change rather than me going into detail now. It will change, and so MCS are just in the process of updating the noise calculation to take account of that change, because the biggest impact for us is that you no longer will have to be a meter away from the edge of somebody's property, which if you imagine you're working in anywhere kind of Londonish with long narrow gardens, managing to put a heat pump a meter away from the boundary is a nightmare. So that will go, but obviously that means that the noise calculation is going to change. So yeah, it's all a bit up in the air right now on that, but can be a challenge to meet the requirements, particularly in urban areas. But heat pumps are definitely getting quieter. And one thing that they've changed as part of the planning change is that heat pumps can be slightly larger, because what's happening is in order to make the unit larger, the physics is meaning, sorry, in order to make the unit quieter, the physics means that you need to make the unit slightly larger. So planning is changing to allow slightly larger units because they are quieter. So yeah, all a bit all over the place right now.
Okie doke. No, thanks for that. Thanks for the explanation. Full session there. Really enjoyed it. Thanks to everyone for asking loads of questions and attending. It was good to see that everyone who registered attended. So that's cool. Doesn't often happen that way. Leah, Richard, thanks for your time. Really, really appreciate it. I'll share the details on Meshwork. I'll add. I mean, obviously, people can find you via LinkedIn, YouTube, etc., etc. So do reach out to Richard and Leah. They can obviously help you work wonders. So yeah, thanks all. Have a good afternoon, and I'll see you next week. Cheers, guys.
Thank you.
Thanks very much. Cheers.